Yeah, welcome. Good morning. If I look jet-lagged, it's definitely not the hour from Munich to here, but more like the coming back from the States just yesterday. But I hope it's going to be entertaining enough and funny enough. Who I am, who actually? Yeah, I'm Markus, a German trying to speak English. That works pretty well for me since a couple of years already. People tend to call me developer advocate, which is a fancy kind of thing. So, what do developer advocates do? Short words. We had an engineering meeting just a couple of weeks back in Berlin, and almost all of our engineers were there. It was pretty cool. And I spent literally the whole day explaining to them what issues our users actually have. Sorry, should be. It was flickering and all on. Yeah, fair.
Oh, that looks better. So I was talking to them like for a complete day and explaining all the issues the Lagom users actually had with the software they built. So that's obviously developer advocacy. Being in the field, talking about our stuff, presenting our stuff, getting you excited about it, to try it out and reach out to me and tell me what's wrong or shitty, or if you like it or not. What else do I do? I'm actually a Java champion, which is a little bit weird for Lightbend because we're known for Scala. So the company formerly known as TypeSafe, yeah, that's true. So it's not Prince. What else do I do? I blog, I Twitter. You can follow me online, obviously, quite a bit. Lately, it's been a little bit more slow on my blog, but I promise to catch up again. One of the main things I did in my past actually was to contribute to the Java EE7 expert group. Building one of those classical, wonderful specifications we all work with, hopefully. And this is the time where I'd like to know a little bit about you. Who's actually using Java EE as main technology these days? Or anything else, like Tomcat? Fair enough. A couple of things. So the rest is Spring. What else do I have? Shout at me. It's going to be interactive anyway. I don't want to fall asleep. No way. So we had Spring, Java EE.
Go!
Go! Go is totally hot these days, absolutely. Anything else we missed? Huh? Node. Oh, congratulations. So yeah, because I've been in Java EE for literally almost 14 years, so I've been a consultant in the field, so working with customers. I've not always been in front of stage and talking about software. So a Java EE example is something that I really like to show you. This is probably something that you all have seen more or less, like a REST endpoint for an AJB. Pretty fancy, right? So we're calling a couple of services, then got to dependency injection. This is kind of the monolithic way of building applications, right? And what microservices do is actually taking apart those old Ferraris, those old things that's been running in the basements for, what, 20 years? No, it's not, but at least 5 to 10 years was the average time that big enterprise applications have been running with my customers. So yeah, taking them apart according to microservices principles today is kind of fancy. And if you do that, you end up having weird code. Assuming you're only using what Java EE has to offer at that point. You just have to introduce new client libraries, you have to call your other services. It's all looking a little bit messy. And this is literally what most of the Java EE-based vendors actually want to sell to you these days. So just to slice up your monolithic application, put a little bit of REST services on top, and try to make them talk to each other. And you're done. That's exactly what Java EE is about today when we look at it as a microservice perspective, especially like those big servers. This is definitely not something we want to do, and this is definitely not something you should even consider. What's for sure is that building one microservice is the easiest thing on any platform. And if I see people like Josh Long doing something great on Spring Boot and firing up like 1 or 2 or 3 microservices, I'm pretty impressed. That is easy. But this is anything but a system. a system of microservices should be more around 10 plus services, right? And assuming that you need to integrate all of those individual services into something that is still functional at the end of the day and fulfills your business requirements, which is the most important part. This is the real challenge behind that. And if you look at all the existing frameworks out there, this is exactly what they're good at, helping you building the first microservice. And you're left alone with all the others. Assuming you stick to something that you have in your monolith, right? You have complex deployments, even for Tomcat. You need a couple of things. Virtual machines, you need your JVMs, you need your application runtime, whatever that is. You need to build your deployments, you need to deploy those things. And listening to Oracle, or maybe Big Blue these days, slicing up monolithic applications, this is exactly what they are talking about. Those old, outdated, standard centralized infrastructures. Fine, easy, totally perfect. Running those things into production is another story. Large teams actually are something that I've seen a hell lot. I've been called a principal architect when I've been using when I've been used as a consultant at my ISV. And make a guess what the biggest project was that I had to work on in terms of developers. Throw numbers at me. Nobody heavy to, huh? 100. We're getting there. Anybody else? It's not even close, by the way. It's actually 200 people working in one project. It's been like 4 business analysts, 2 quality engineers, 3 DBAs because somebody had to make JPA work. It's been all kinds of people involved into those enterprisey systems, right? And if we're, as consultants, as developers, hit bigger accounts these days, and enterprises are all about modernization these days, this is exactly the scenario we're going to face. And the reason for modernization is the right reason. Business tend to develop a lot faster these days. Thanks to the EU, which is a very, very perfect thing to develop new laws, for example. And those new laws have to put into practice in the individual member countries. And whatever time they take to develop those things, that might be 5 to 6 years. But having the legislative out and having to put them into production in Germany might be a time frame that's kind of under 1 year, which is typical for enterprises who don't embrace continuous integration and aren't agile right now. So those large teams and those, let's say, individual requirements that you find in enterprises, let's just assume that breaking up our monolithic applications, not only team-wise but also technology-wise, will end up in a tremendous disaster. And splitting monolithic application basically means adding a lot more complexity than we would have assumed by gaining through having a wonderful microservice-based system. And this is actually not about having less lines of code. It's actually not about having less people. It's about having to talk a lot more, right? So splitting monolithic applications is a simple sentence which is easy to say and very hard to put in practice. And if I've learned something over the last couple of years, it's actually technology won't solve your issues here. So whenever I talk about Lagom today, this is the technology layer. Please don't forget that there's a lot more methodology. Daniel actually, thanks for being a host today, gave a couple of great talks around what it really means to put microservices in production. I'm still scratching on the bottom tech layer here. Which technologies should you choose? This is a nice graphic I found a couple of weeks back. It lists the amount of users, connected devices on the internet. And if we're looking back here in the Java EE J2EE days, this is where we started with just a fancy couple of people working with browsers. And we came a long way to almost 4 billion. And microservices, as you can see, is not exactly an old thing. That came up very, very, very long ago already in terms of IT technology times. There's pretty much everything on here. Ruby on Rails, Spring, Akka. So yeah, what's the right technology to choose for microservices? There's actually no right technology choice, at least not for me. I think I'd approach it from a different angle. If we're talking about an insane amount of connected devices, an insane amount of business requirements that we didn't actually know when we started to build our software, then one of the main things that we start to see is that we're no longer talking about data in terms of sitting in a database and waiting to be worked with. We're talking about data that is constantly in motion, that is constantly flying around. I think one of the scariest examples is the insurance industry. So they started to equip your cars with all kinds of sensors, and they are trying to figure out how you actually drive. And the better your risk profile is, so the less risky you drive, no speeding, no tickets, no sharp corners, no accidents for sure, the lower is your insurance price. And this data is actually coming in constantly into the systems of the insurance, right? And they have to act constantly on whatever you do with your car, no matter how you drive it. They just want to have the end result and want to calculate a policy for you. So instead of just streaming everything into a database and having another nightly batch job going over it and trying to figure out what happens, this data is a constant stream. And depending on what this stream actually tells you, you want to act immediately and do something with it. And this is, to me, the most important part for technology choices behind those microservice-based architectures. Being able to work with streams of data, being able to work with streaming in between services. I'm pretty sure you can do that on all kinds of technologies, but Lagom definitely is one part where you can have first-class support for that, surprisingly. One thing to me is definitely sure, and this is a quote like Gartner. Who, as a developer, reads Gartner? This is good for one thing, right? It's good to convince our architects and our management people to not do something. So whenever you find a Gartner quote, you're pretty much covered. That's awesome. So yeah, whatever you have in the basement, whatever you used to do in terms of centralized monolithic infrastructures is probably not the answer to all those new problems that we're facing today. Thanks, Gartner. That helped a lot. What we did do, actually, we used a couple of those tools already. We just didn't really build the things as we would like them to build, knowing all the implications of microservices these days. And we're missing a hell of a lot of stuff, actually, if we're looking at those centralized servers. We're missing service discovery. We're missing lookups, API management, the complete field, including security. Protocol and interface definitions. Is REST like the solution to all your problems? Speaking about REST over HTTP, is that a good thing to do or not? Do we want to do that? Who's in favor of REST over HTTP for the standard microservice communication protocol? Okay, now I want to hear all the other options. Who's not in favor of using it? Okay, who has an opinion at all? Good morning, yes, thanks.
It's not a protocol, is it? It's a design.
REST is an architectural pattern. Usually when people talk about REST, they assume it's REST over HTTP. So I haven't seen a hell lot of good implementations that are not HTTP based. So that's pretty much why this more or less one-on-one connection came through. So is it a good idea or not? Obviously not, right? Is REST asynchronous? Per default, like REST over HTTP, the implementations we know as of today, used in Java EE and almost all big frameworks? No, they're all synchronous. And even the specification for JavaLand, like on Java, is definitely not asynchronous. It's not even specified. Individual frameworks can do that, but it's definitely not specified. So it won't help us a lot. We need to find something else, or need to find an asynchronous implementation that suits our needs at that point. Data access is another great thing. I used to rant over classical database access, JDBC and JPA, because mostly I've been suffering for years. It's been amazing. You can access all kinds of data via a very standardized protocol. Everybody of us knows SQL. We all know the JDBC API. It's so easy and straightforward. Especially JPA makes that so great. Like if you're only a Java developer and you don't know anything about databases and you think you can just throw a couple of objects into your database, that's amazing. The first thing that happens after, like the day after you go into production with reload, you're crawling into your DBA's office, like on all 4 feet, and you're begging him to have a look at something that didn't work in production. And he takes a zip out of his coffee cup, smiles at you and says, "Sure, for you." And then he starts. And he tweaks a little bit, some magic, DBA, database, Oracle, whatever. And you come back relieved, having a cigarette, wiping off all the sweat from your face, and you get a call, something else broke. Exactly same database, exactly same data, but after the DBA tweaked something that made your write side optimized, you ended up having a really imperformant read side, and all your reports are now directly hitting the wall. So, what did we learn? We can only optimize database access via the existing APIs for exactly one scenario, for read or for write access. And this is something that JPA is absolutely bad at. And looking at just even JDBC, for example, those are scenarios that don't support the way we used to work with data and microservice-based architectures. So working with endless streams of data coming in, going out of the system, requires performance on both ends. We can't just limit ourselves to maybe something in the middle. Mediocre is just the worst that we could achieve for. So we need new data access ways, new ways to handle data and store data. And last not least, developer experience. That's something that I had so many awful experiences with, starting with 20 terminals firing up individual microservices and trying to debug something. That's amazing. If I have a system of 40 microservices and I really want to try out something like on my local machine, do I really have to start all of them? Do I really have to have like a complete operational infrastructure here? Do I have Docker locally installed in Swarm and Mesosphere or whatnot? That's amazing, because I'm not an operations guy. I'm just a poor, simple-minded developer. I really want to have my code, and maybe a JVM. I know those two. So yeah, developer experiences in terms of distributed applications, that's something I haven't seen a lot so far. So we're actually going to skip that. If you want to learn a little bit about why REST isn't the solution, give that video a shot. I hope Daniel's going to distribute the slides afterwards. Okay, I told you a lot about ways that microservice architectures don't work. And because I've always wanted to cite myself on a slide, I actually came up with this wonderful idea, because I realized that whenever I tell somebody what not to do, I kind of cheat of one of the most important things that made of my career for the last 14 years. I've been working on those monolithic systems. I read millions of books. I learned everything that has to be learned to build perfect Java EE centralized infrastructures. And now somebody is standing in front of me and telling me I should forget about all that. So good news. whatever you've learned about designing software, whatever you learned about architecting software is relevant, and it will stay relevant. And the more you distribute your applications, it's actually even more important. And you probably have learned a lot about the basic principles behind microservices, so I'm actually not spending a hell lot of time here. What I found very, very helpful is, especially when going into enterprise accounts, they had their experience with something that we all know with the SOA acronym, right? So service-oriented architecture is something which they try to make work for many, many years already, and they learned a bunch of lessons during that. And I think it's safe to say that we can actually take some of those lessons and still apply them even to microservice-based systems. The rest is pretty straightforward. Software design patterns is a little bit of a different animal. If you are really working on distributed microservice-based systems, this is a very narrow field, and we have a couple of patterns that at least the typical enterprise Java developer doesn't really know about. Most importantly, I think, to me, domain-driven design is the one thing that really leads to the correct service boundaries. If you're not familiar with that, then you're definitely missing something. You can still say, I have a big belly and I can absolutely make perfect guesses on service sizes. I'd not go down that route, definitely not. So domain-driven design, to me, has been proven to be the one solution to your software design. And even if you're not familiar with that, and I know that many enterprises tend to not having done that in the past, this is something that we need to work on as an industry. Event sourcing is a principle that we also won't find in many enterprise accounts these days. There has been a couple of years in between where something called complex event processing has been kind of a trend, but it never really took off. Maybe because it's been the first try on real distributed systems. I personally believe for microservice-based systems, event sourcing is one of the core tenets that we definitely need to embrace. And I don't know if you need to learn a lot about it, because I think the framework needs to encapsulate that for you and needs to have really good ways to make it usable for you without having to have like a master degree on it. CQRS, command query responsibility segregation, is probably the solution to the read-write side problem I touched on earlier. You can for sure use CRUD wherever you want to. But if you really have to work on a lot of data, if you really have to make every single operation count in terms of performance, CQRS is a perfect pattern to achieve that. More importantly, what we maybe haven't learned from SOA-based systems and implementations is the issue with eventual consistency. So learning to generally embrace failure instead of working against it. So our systems will fail on various levels, and embracing them, generating throwaway data just to be performant and very, very straightforward might be something that we definitely want to do in distributed systems. To sum everything up, this is probably what we need to learn, and this is a quote from a former Red Hat coworker of mine. What we've been trying to so far is that we've tried to build efficient and robust systems. And microservice architectures are kind of turning that a little bit around and enable us to build applications that are flexible and resilient. And this is something a little bit more than a simple mind switch from building monolithic applications. The core tenets of microservice-based systems fit very well into something that you all have probably seen before. Those are the 4 tenets of the reactive manifesto. So building reactive applications, building distributed applications is a pretty amazing thing, and it is pretty close to what microservice-based architectures require in general. And I'm definitely not going to dig into that because there's a lot of speaker notes to read out here, which I'm not going to do. The funny part is there's been technologies out there since ages that can definitely implement perfectly fine microservice-based systems. Akka is a good example. Play is a good example. The main drawback of those technologies always has been for Java developers that it's mostly Scala. I acknowledge that. It's not going to change. We also have Java APIs. So as of today, you can look into Akka and Play and just build your microservice-based application. You just have to do a lot of heavy lifting yourself. There's no service discovery in the broadest sense. There's no API management solution built in there. And you still will have to build a couple of scripts to make that whole thing work. I'm not even speaking about developer productivity at that point. But obviously, also a great technical solution that just don't provide all the assets and add-ons that we really need. And this is finally where Lagom comes in. And if I would have to describe Lagom, I think it's a usability and developer convenience layer on top of some very, very mature technologies that have been there since ages. And it gives you a very, very opinionated way, including some straightforward APIs that actually allows you to implement microservices. And we don't like the word micro, don't we? Who loves micro? Is that a perfect name for what we're trying to do? Oh, I know, I'm the only one between you and lunch, but please. So, no, it's shitty, right? I mean, whoever came up with that, it's just stupid. It is not about size, it's not about lines of code or kilobyte jar files or whatever. It's about just the right amount of something in terms of feature, in terms of capability. And lagom is actually a Swedish word, which means just the right amount, just enough. So yeah, when you have like a Swedish party and you have a plate with cookies on the table, there'll always be one cookie left because nobody's definitely going to take that one. Everybody is fully sufficient with a little bit, with the right amount. And that's really good explanation for the name Lagom. It gives you a lot of developer experience. You'll see that hopefully, maybe, eventually. It gives you a couple of pre-defined APIs that we're definitely going to look into it. What we definitely recognize at that point is that Lagom is highly opinionated. So it's not your hammer nail tool kind of thing. You really need to want to build a microservice-based architecture. Lagom is not meant to build a monolithic application, in no way. And it will exactly guide you through the steps that you want to implement. It's not giving you a lot of playroom left and right at that point. Bottom to top, it comes with the service API. Very straightforward, no Java annotations in that, like a really solid API that you could use. I/O and communication and streaming communication are first-class citizens in Lagom. You don't have to care about that. Lagom does exactly that. The complete service communication is asynchronous and you don't even have to implement anything. Streaming between services. WebSockets as technology, for example, is a great thing, and Lagom does that out of the box, without you having to implement anything or using anything beside the Lagom service API. Endpoints, we do support REST endpoints, but it's not meant to be the first-class citizen. Actually, I'm going to point you to a more detailed example because I don't want to make the mistake of showing you something that I can't finish in 30 minutes. It's going to be definitely tough, but I'll point you to an extensive example where I can play around with. Lagom Persistence API is also very straightforward and absolutely opinionated. You can't just use CRUD with it. It's just meant to give you a framework to implement CQRS-based persistence. And everything is backed by event sourcing that you also don't have to look in because it's deeply built into the framework, which ultimately leads to something like CQRS. Do we want to use CQRS everywhere? Probably not, right? So I just gave a talk in Chicago for the local Java user group just about CQRS and event sourcing, and that was like an hour and it felt like an overview. So it's definitely something that you need to look into and learn about. It's nothing that you could just use. But there's definitely the break-even point where all your efforts pay off. If you come to a reasonable complexity in your domain model, then you definitely will have a lot of performance gains out of using CQRS. When you're not there, you can totally use CRUD, but then please don't use the Lagom persistence API. Then you just need to use the standard integration patterns that Lagom offers. What else do we have? The development environment. I'm actually using Activator here, which is like the start product where I can have a bunch of templates and just fire off here individual projects. Behind that is SBT as a build tool. And SBT is a lot more than just a build tool. It actually is kind of a development environment. And the most important part here is you can fire up all your local services in one VM for development purposes. Instead of having to distribute everything via some kind of technology underneath, and I'm not even judging at that point, for development purposes, Lagom replaces all the service discovery and linking features with Google Juice, and actually have the services talk directly to each other on one VM. So run all as a command in Lagom allows you to start up the complete infrastructure, for example Cassandra, the service gateway, the service locator, plus your services in one command on one VM, which is pretty neat. Seriously, you don't have to distribute, package, build. You can just develop. And code replacement, actually hot code reloading, works in that complete scenario. Technically behind Lagom, as I said, Lagom is a very, very thin layer on top of something that has already been out there for many years. So you find a couple of already known players in the reactive application realm. Scala for sure. Actually, Lagom is written in Scala, but it only has a Java API right now, which is kind of funny. Play Akka Cassandra as a database solution. For now, it's the only database solution that we support, at least for CQRS-based persistence with a Lagom persistence API. If that's not enough, we can use what we always did, and this is the funny part. So this is kind of the architecture and API overview of Lagom, and the interesting part is down here. So most of it is backed by Akka persistence, Akka streams, and Akka cluster. And especially with Akka streams, we have a bunch of features that we can use to connect to existing protocols, existing backend systems. And I don't know how you assess your microservice engagements from now on, but I bet that at least 80% of them are actually trying to modernize an existing monolithic application. And only very few will be pure greenfield developments at that point. And if you can't connect to something that's been there in the basement for even longer than the monolithic applications, then you're probably doomed. And I'm pretty happy that we have a wide variety of technologies that we can connect to. And I'm probably spoiling a little bit here, but for now it's actually the Camel Akka connector that's mostly used here. This is probably going to replace very soonish with our own streams implementation towards a couple of those protocols. But it's good to know that you can actually link in there from whatever you want to do. If you need to change the persistence, you have a couple of options. Play has a JPA module. use with caution. I actually talked about synchronous versus asynchronous access. JPA is definitely synchronous. So building that into your asynchronous microservice designs definitely is something that you probably think twice about or encapsulate well and put it aside. What's coming next for Lagom? It will have a Scala API at some point, which is something that many people have been waiting for. I've seen a couple of eyebrows going up when I talked about service integration and Google Juice and service discovery on one VM. Actually, there is kind of a binary coupling in between services in Lagom right now. This is definitely going to be resolved with the help of Swagger. Instead of having those binary dependencies, we're actually going to use a Swagger description to look those services up and have a real decoupling between the services. Also, another big thing for me, SBT is kind of a wild beast, and if you've never worked with it as a Maven well-known developer, then you probably will have a steep learning curve. So Maven support is coming. Hang in there. And we're also going to roll out more support for more DBs beside Cassandra. If you're missing something on the roadmap, feel free to reach out to me. I'd be happy to talk to the team and see if we can put something in there. And because it's like only, a couple of minutes left, right? I'm definitely not going to show you how to run Lagom. I'm only going to point you to a very, very simple example. The cargo tracker example is something that people know who've been working with domain-driven design. And we started the first run on implementing it with Lagom. First run because it's only 2 services right now. Couldn't be one because one is obviously no system of microservices. Backed by Cassandra, a little bit of a front end written in Play. That's actually not true. I think it's React as a front end. It's just a Play wrapper. But it will give you a very, very good overview about Lagom. You can learn a lot about Lagom if by visiting the GitHub project. I did mention that it's Apache licensed open source, right? So it's nothing you have to buy. It's something that I really ask you and beg you to participate and contribute in. We've seen a couple of our partners picking up Lagom and giving extensive feedback about it. I think it's a very, very great way and a very complete way of addressing the complete microservices space. And from the Lightbend side of house, there are a couple of partnerships upcoming that will make running those Lagom-based microservices in cloud infrastructures a lot easier. And you could be very surprised about the upcoming announcements. How did we come up with Lagom? What was the basic idea behind? Because everybody wanted to have a microservice framework, maybe? I don't think so. That's definitely not what we do. So Jonas Bonner, one of our CTOs, wrote a little bit about reactive applications and how they relate to microservices. And this is, fancy enough, a free ebook that you could just download. Just give us your email address and you're ready to go. And this is the architectural blueprint for Lagom. So if you really want to know about all the details, this might be a good starting point. And because I don't really like to be the person behind the CTO talking about what he did, I decided to actually also write a book. And I thought, no, I don't want to talk about architecture. That's stupid. I've done that for so many years. So I'm going to talk about the implementation of microservices. And this thing is actually walking you through the cargo tracker example, explains, I'd say 80% of the source code lines in there, and is a very good read, like a getting started document if you like to, for your first Lagom experiences. Next steps in the journey are pretty much trying out Lagom, downloading, installing, playing around with it. Documentation link is probably a little bit outdated, but you should get there from the official website. We're that close, even if we're recorded today, to releasing Lagom 1.0. At the moment, it's still like a I think it's a release milestone build, so technical preview, but it's good to go and ready to be tested out. If you want to put it into production as of today, you will need Conductor, which is a Lightbend product, but it's free for development, so you can even play around with that. But you don't have to, because the local development environment is totally sufficient for now. And there are a couple of exciting alternatives upcoming, so again, let's keep the eyes open and be curious about the next steps. If you have questions, I'd be happy to take them. So I'll be around 3, maybe 4 p tonight. Happy to show you something, like we can look together at the cargo tracker example. Otherwise, thanks for having me. Have a good lunch and talk to you later.